Good morning. Rohini College of Engineering and Technology, accredited with A plus grade by NAC, Department of Civil Engineering, CE 3402, Strength of Materials, Regulation 2021, A. Anand, Assistant Professor, Department of Civil Engineering. So today we are going to see the topic Mohrs circle. So Mohrs circle is a graphical method for finding normal, tangential and resultant stresses on an oblique plane. Mohrs circle will be drawn for the following cases. The first one is a body subjected to two mutually perpendicular principal tensile stresses of unequal incentives. A body is subjected to two mutually perpendicular principal planes stresses which are unequal and unlike. One is tensile and other is compressive. And third one is the body is subjected to two mutually perpendicular principal stresses, tensile stresses, accompanied by a simple shear stress. So here there is a Mohrs circle when a body is subjected to two mutually perpendicular principal tensile stress of unequal intensities. Considering a rectangular body subjected to two mutually perpendicular principal tensile stresses of unequal intensities, it is required to find the resultant stress of an oblique plane. Let sigma 1 is equal to major tensile stress, sigma 2 is minor tensile stress, theta is angle made by the oblique plane. So we can see the problem one by one. The first problem, the tensile stress at a point across two mutually perpendicular planes are 120 Newton per mm square and 60 Newton per mm square. Determine the normal, tangential and resultant stress on a plane inclined at 30 degree to the axis of minor stresses by Mohrs circle method. So given data, major principal stress sigma 1 is equal to 120 Newton per mm square. Minor principal stress sigma 2 is equal to 60 Newton per mm square. Theta is equal to 30 degree. To find the normal, tangential and resultant stress. So solution, the first sigma 1 is equal to 120 divided by 10, 12 centimeter. Sigma 2, 60 divided by 10, 6 centimeter. So take any point at A and draw the horizontal line through the A. Take AB, sigma 1 is equal to 12 centimeter AC. So by using this diagram we want to mark the values. So here we are making this by measurements. Length AD is equal to 10.50 centimeter, length ED is equal to 2.60 centimeter, and length AE is equal to 10.82 centimeter. The normal stress is equal to length AD into scale is equal to 10.50 into 10, 105 Newton per mm square. Tangential or shear stress is equal to length AD into scale is equal to 2.60 into 10 is equal to 26 Newton per mm square. Resultant stress is equal to length AE into scale. And second problem, the stress at a point in a bar are 200 Newton per mm square tensile and 100 Newton per mm square compressive. So determine the resultant stress in the magnitude and direction on a plane inclined at 60 degree to the axis of major stresses. Also determine the maximum intensity of stress, shear stress in the material at the point. Given data, major principal stress is sigma 1 is equal to 200 Newton per mm square, sigma 2 is equal to minus 100 Newton per mm square. And angle theta is equal to 90 degree minus 60 degree is equal to 30 degree. To find the magnitude and direction, resultant stress and maximum intensity of shear stress. Solution, sigma 1 you want to calculate, that is 10 centimeter, and sigma 2 that is minus 5 centimeter. So Mohrs circle is drawn as, so take any point A and draw the horizontal line through them on both sides of A and shown in figure. From E, draw ED perpendicular to AB, join AE and C. Then the normal and tangential stress on the oblique plane are given by AD and ED respectively. The resultant stress on the oblique plane is given by AE. So this is the figure we have shown there. So length AD is equal to 6.25 centimeter, length ED is equal to 6.5 centimeter, and length AE is equal to 9 centimeter. The normal stress is equal to 125 Newton per mm square. Tangential stress is equal to 130 Newton per mm square. Resultant stress is equal to 180 Newton per mm square. So this is the problems you have seen. Thank you.